Hi. In this video, we are going to take a look at the LM2596 CC, CV module with 3 potentiometers. We will learn the principle of operation through schematics, and take a close look at the functionality of the third potentiometer. I also have an interesting video introducing the operation principles of the buck converter, so for those who are interested, I will share the link on the explanation below. And through the demonstration of charging the 18650 battery, I will also introduce the limitations of charging the battery using this module. The front view of the 3-pot LM2596 is as follows. The device shown here is the LM2596 buck converter IC. It is also called a switching regulator because it controls the output voltage by switching on and off the output. This part is the input stage. The input range is limited to 7 volts to 30 volts due to the 78L05 LDO used in the module. Of course, the rated voltage of the 220 microfarad capacitor at the input terminal is 35 volts, which is also a limiting factor for the input voltage. This part is the output stage. The output voltage range is 1.23 volts to 30 volts. A potentiometer close to the input is intended to control the output voltage. Turning clockwise increases the output voltage. The potentiometer near the output stage is intended to limit the output current. Turning clockwise increases the amount of current that can be output. The potentiometer in the middle is a charge control that controls when the charge indicator LED goes off. Turning it clockwise increases the output current level that the CH LED turns off. In other words, the CH LED turns off at a higher current. The LED close to the out plus port is CC indicator LED, and it turns on when this LM2596 module is operating in CC mode, that is, when the maximum current set by current control is being output. The LED here in the below is a OK LED, it has an exclusive relationship with the charge indicator LED. That is, when the charge indicator LED turns on, the OK LED turns off. Let's take a look at the back. There seems to be nothing on the back, except this maze-like pattern here. This performs the current sensing, which is used to limit the output current. It is also called trace resistance. All objects have resistance, and as the length increases, the resistance value increases. The larger the cross-sectional area, that is, the thickness and width, the smaller the resistance value. By using this characteristic, it can be used where a small resistance value is required. By measuring the resistance value indirectly, approximately 0.026 ohm can be acquired. It is a nice way to save the material cost of one big resistor we have seen in the 2-pot LM2596 module. Now, let's take a quick look at the circuit of the 3-pot LM2596 module. As I mentioned in the intro, for more details, take a look at one of my videos introducing the operational principles of buck converters. Now, let's take a look at the circuit diagram of the 3-pot LM2596. There is no big difference from the 2-pot LM2596, so let's focus only on the differences. This is a sense resistor designed with the trace resistance. As the output load current changes, a potential builds up between the negative ports of the input and the output. Therefore, when the positive input of the LM358 becomes larger than the negative input due to the increase of the output load current, the output is driven to turn on the CC, CV LED, and it takes over the control of the feedback pin of the LM2596. This part is controlled by the third potentiometer. When the output load current increases, the voltage of GND1 increases, and when the voltage of the negative port of LM358 becomes greater than that of the positive port, 0 volts is driven as an output. As a result, the CH LED turns on and the OK LED turns off. When the output load current decreases, the voltage of GND1 decreases, and when the voltage of the positive port of LM358 becomes greater than that of the negative port, 5 volts is driven as an output. As a result, the CH LED turns off and the OK LED turns on. Let's take a closer look at the operation of the third potentiometer. This is a typical graph when charging a battery, where the load current decreases with time. This threshold is controlled by the third charge control potentiometer, and if the load current is larger than this threshold, the CH LED turns on, and if the load current is lower than the threshold, the CH LED turns off. Turning this potentiometer clockwise will raise this threshold, and turning it counterclockwise will lower it. In the beginning stage of charging a battery, the load current is typically greater than the threshold, so the CH LED stays on, but when charging is almost complete and the load current is lower than the threshold, the CH LED turns off. Manual check is required, and charging does not automatically stop, so it is recommended to use a battery with a built-in protection circuit if possible. Let's look at a simple demonstration of how to set up a third potentiometer. Here is the demo configuration. Power supply is 12 volts DC connected to the input of 3-pot LM2596, and voltage control potentiometer is set to output 8 volts. I will check when the CH LED changes state by controlling the charge control potentiometer and the load current of the variable load. A 2-pot CC, CV LM2596 module was used for the variable load, by adjusting the current control potentiometer, with output short-circuited. This is the configuration I've explained. Now let's turn it on. When the power is turned on, 8 volts appears at the output of the 3-pot LM2596, which connects to the variable load through the INA219. Now I will connect the output of the 2-pot LM2596 to the current measurement terminal of the multimeter, which will effectively short-circuit the output. As you can see, the amount of current measured by the multimeter is 300 mA, which was preset by the current control potentiometer of the 2-pot LM2596. The LED of the 2-pot LM2596 turns red, indicating that it is operating in CC mode. The output current of the 3-pot LM2596 is currently 58 mA, and the red OK LED is on, which tells us that the threshold set by the charge control potentiometer is higher than 58 mA. Now let's lower the threshold by turning the charge control potentiometer counterclockwise. Now since the threshold is lower than 58 mA, the CH LED turns on. Then, let's lower the current of the variable load and see what happens. As we lower the load current, the CH LED turns off, indicating that the charging is complete. Since the CH LED turns off at about 50 mA based on the 3-pot LM2596 output, the threshold is set to 50 mA. In this way, you can set the point where the CH LED turns off when charging the battery. The following demo is a demonstration of charging an 18650 battery using a 3-pot LM2596. For this demo, the LM2596 output is set to 4.2 volts and the current limit is set to 1 ampere. For safe charging, it is recommended to charge with a current less than half the capacity of the battery. Also, I will use INA219 to measure and log the charge profile during the charge. For demonstration purposes, a completely discharged, built-in protection circuit 18650 battery was used. Then, let's connect the power. As the power is connected, the CH LED turns on, indicating that charging is in progress. The current is about 1 ampere, but the CC LED does not turn on, indicating that this module is operating as a CV mode. After charging for about 8 hours, I stopped the charging and the charge profile was checked. It is showing a typical lithium-ion battery charge profile. If you look at the right end of the charge profile, you can see that charging continues as the current decreases, but never stops. This is due to the fact that this 3-pot LM2596 module is not equipped with a built-in overcharge protection function. And this is why you should use a battery with a built-in protection circuit when charging with this module. Finally, I will briefly summarize the contents introduced today. Each potentiometer of the 3-pot LM2596 module is used for voltage and current output and charge indication control respectively. When charging the battery using the 3-pot LM2596 module, it is recommended to use an 18650 battery with a built-in protection circuit. Also, when purchasing a buck converter module with a constant current function, check whether the output current drops to 0 by adjusting the current control potentiometer. If it does not, good chance that the module is defective, so please be sure to get a refund. This concludes the introduction of the 3-pot LM2596. See you later with more videos. Thank you.